Welcome to our journey through time to explore the evolution of Mars, a planet that has intrigued scientists, space enthusiasts, and dreamers alike. From its fiery beginnings 4.5 billion years ago to the possibilities for its future, join us as we uncover the mysteries of the red planet. How has Mars changed over the eons, and what could its future hold? Let's find out. Our story begins 4.5 billion years ago. In the early days of the solar system, chaos reigned as planets were forming from dust, gas, and debris. Amid this cosmic dance, Mars was born. The planet was young, hot, and spinning rapidly. With its molten surface and high-energy state, Mars was a fiery, uninhabitable world with no signs of life. At this stage, the surface of Mars was covered with molten lava, and the landscape was cracked and unstable. It was a harsh environment, filled with volcanic activity and intense heat. Not a place you would imagine life to exist. Fast forward to 3.8 billion years ago, and things start to get interesting. Mars was undergoing significant changes. As its molten core began to cool, a new chapter opened for the red planet. Surprisingly, around this time, life was beginning to emerge on Earth, and evidence suggests that Mars might not have been so different. Research from NASA indicates that Mars was once covered by a vast ocean, covering about 1/5 of its surface. Imagine a Mars with rivers, lakes, and maybe even rain, a far cry from the dry and dusty desert we see today. However, this watery world didn't last forever. As Mars lost its magnetic field, it started losing its atmosphere. Solar winds stripped away the protective layer, allowing water vapor to escape into space. Scientists estimate that Mars lost about 87% of its water this way. What remained was stored as ice at the polar caps, the last remnants of a once more habitable world. As we move further along Mars' timeline, we come to a period between 2.1 billion and 400,000 years ago. This era marks the Martian Ice Age, a time when Mars became a cold, barren, and inhospitable planet. Mars became increasingly cold, and its once flowing rivers and oceans froze into massive ice sheets. Scientists have discovered evidence of these ice ages through data collected by NASA's Mars Global Surveyor and Mars Odyssey missions. These studies show that changes in Mars' orbit and tilt caused its poles to heat up, triggering a release of water vapor and dust into the atmosphere. These particles would then settle at around 30 degrees latitude, forming layers of ice and dust. Despite these dramatic climate changes, Mars' environment became more like a frozen desert. Any hopes for life on the surface faded, and Mars became a dead planet, or so it seemed. Today, Mars is a cold, barren desert with a thin atmosphere composed mostly of carbon dioxide. Its surface is covered with iron oxide, giving it that signature reddish hue. During the day, the sky appears pink due to dust particles suspended in the atmosphere, but at sunset and sunrise, it turns a striking shade of blue. We have sent numerous missions to explore this desolate world, from the Viking landers to the recent Perseverance rover. Yet we still wonder, is there any life hiding beneath its surface? Some scientists believe there could be microbial life lurking underground, protected from the harsh surface conditions. But as of now, the red planet remains largely silent. So what does the future hold for Mars? Let's leap forward 100 years. Humans have finally set foot on the red planet, a dream that has fueled our imagination for generations. This marks the beginning of humanity's greatest adventure, the colonization and possible transformation of Mars. The first step, introducing specially engineered bacteria that can survive and thrive in Mars's harsh environment. These bacteria would consume carbon dioxide from the atmosphere and produce oxygen, slowly transforming the planet's atmosphere over time. It's a small but significant step towards making Mars more Earth-like. Fast forward another 1,000 to 10,000 years. Mars is undergoing a slow but profound transformation. The bacteria released by the first settlers have spread across the planet, and other methods to warm the planet, like deploying large mirrors to reflect sunlight, have started to pay off. As the ice begins to melt, more water is released, and Mars's atmosphere thickens. The increased water vapor helps trap heat, raising the planet's temperature. We start seeing signs of a green Mars, perhaps the first stages of a fully terraformed world. Yet this process is still far from complete. Now, let's take a giant leap into the distant future, 100,000 years from today. Imagine a Mars covered with lush forests, flowing rivers, and vast oceans. The atmosphere is now thick enough to support not just microbial life, but perhaps even plants and animals. It is a sight to behold. Mars has become a vibrant green world, potentially a new home for humanity. But even with all our advancements, transforming Mars completely to mirror Earth remains an enormous challenge. Could Mars become our second home, or will it remain a distant outpost, a testament to human ingenuity and exploration? The evolution of Mars is a story of fire, ice, and endless possibilities. As we continue to explore and learn, we realize that the future of Mars is not just written in the stars, but in our hands. Whether Mars will one day be a thriving world or remain a barren landscape, one thing is certain: our journey to Mars is just beginning.